Hi everyone, welcome back to my channel. And in this particular video I'm going to teach you how to draw the development of a funnel. To be precise, development of lateral surface of a funnel using AutoCAD software. And before going into the question, if you guys like my videos, kindly share my channel and like the videos and my channel also. And now let us look at the question. See, the question states like this. Draw the development of the lateral surface of a funnel consisting of a cylinder and a frustum of a cone. The diameter of the cylinder is 20 mm and the top diameter of the funnel is 70 mm. The height of the frustum and the cylinder are each equal to 40 mm. Friends, as per the question, we have to draw the development of the lateral surface of a funnel. And from the by reading the question, we can come to an understanding that a funnel is consisting of two components. One is cylinder, and the other is frustum of a cone. And in the question itself, they had also mentioned as the dimensions of the both the components. And the diameter of the cylinder is given as 20 mm, and the top diameter of the frustum is mentioned as 70 mm. And in addition to that, the height of the cylinder is 40 mm. At the same time, the height of the frustum of a cone is also 40 mm. Both the things are 40 mm, and the diameter of the cylinder is 20 mm, and the frustum of a cone, the diameter of the top surface of the funnel, top diameter is 70 mm. And before directly getting into the solution, let us first visualize the funnel. Let me get back to the AutoCAD here. And on the monitor, on your screen, you can see a funnel which is generated using the three-dimensional module of AutoCAD 2015 software. Now let me orbit the component for your visualization purpose. And the component where my cursor is moving, and this particular component is known as cylinder, and the top component is known as frustum of a cone as per the geometric standards. Now let me orbit the funnel for our visualization purpose. Okay, this is how my funnel looks. Okay, and now let us look at the individual components. This is the component cylinder. Let me orbit this one also. Okay, and as per the given question, the diameter of this cylinder is 20 mm and the height of the cylinder is 40 mm. Now let us look at the frustum. This is how frustum looks. Let me orbit this one also. Okay guys, and as per the given question, the top diameter of this funnel is 70 mm and the height of this frustum is also equivalent to 40 mm. Now let me get back to the component, and both those components, the cylinder and the frustum of a cone together combine to form a component called funnel. And now we have to draw the development of lateral surface of both these components individually. And before getting into the development side, any development of surface question needs to start with two views. One is the front view and the other one is the top view of that particular component. Now let us see how this funnel looks in the front view. So this is how a funnel looks in the front view. The bottom portion, the cylinder portion, looks like a rectangle and the top portion looks like a triangle, one way or the other. Now let me change the visual style to two-dimensional wireframes. See, this is how it looks in the front view. Now let us also see how it looks in the top view. So this is how it looks in the top view. It looks somewhat like a circle. So now let us start generating this particular diagram. Let me go to a new drawing file, and let me press F7 function key in order to get rid of these grid lines. Now let me go to units, UNITS units, enter. The type should be decimal and the precision has to be, let me give 0.00 precision for this particular problem. And instead of inches, let me go to millimeters. The insertion scale, instead of inches, it has to be millimeters. And now let me click on OK. Now let me give limits, LIMITS limits, enter. The lower left corner is always 0, 0, enter. and the upper right corner. For this particular problem, let me choose 300 comma 300, enter, and let me give, after limits it is mandatory to give zoom all command, zoom, 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 and subcommand all, a, enter. And now first let us draw the front view of the funnel diagram. In the front view, we have to draw the front view of two components. One is the cylinder and the other one is frustum of a cone. Now first let us take a line command. Before that, let me change the model back to drafting and annotation, because I'm going to draw each and everything in the two-dimensional view only right now. Take line. We all have seen the visualization of the funnel. In the front view, the component cylinder looks like a rectangle, and the rectangle length is going to be 20 mm and the height is going to be 40 mm. So let me give a click here. Now press F8, turn on your ortho mode, and this particular direction is 20, enter, and the height is 40, enter, in the vertical direction. Again, in this particular direction, in left hand side direction, the distance is going to be 20 mm, enter. In the downward direction, the length is going to be 40, enter, hit escape key. Now we have drawn the front view of one component of a funnel, that is for cylinder. This particular length is 20 mm and this particular length is 40 mm. Now let us take a line. Now move your cursor towards the midpoint of this line, give a click there, and in the upward direction 40 mm, that is the height of your frustum, 40, enter, escape. And in the given, and it is mentioned in the question that the top diameter of the funnel is 70 mm. So in this particular direction, I need to draw a 35 mm line, and in the left hand side direction also I have to draw a 35 mm line. Let me take a line. Now from this end point, in the right hand side direction, move your cursor in the right hand side direction, type 35, hit enter, escape. Again take another line. Now from this particular point, again in left hand side direction, type 35, hit enter, escape. Now let me take a line. Now join this endpoint with this endpoint, escape, and take another line. Now join this endpoint with this endpoint and hit escape. Now what we have to do is, we have to take another line from this endpoint, draw another line up to this midpoint, hit escape. Now we have got a frustum of a cone here. Now I'll make it a cone by extending this slant line and this slant line onto this line. And the command for extend is EXTEND, extend. Similar to your trim command, extend. After typing extend, hit enter twice, 1, 2. Now click on this line. See, it gets automatically extended up to this line. Now again give a click on this particular line. Click it here, hit escape. So this is the front view of the funnel of given dimensions. Now let us give dimensions for this one. Let me go to linear, click here, give another click here. Now drag your cursor in the downward direction and just give a click. Though we have given dimensions, it is not visible. So let us get back to dimension style manager, D, enter. Let me go to modify. Let me go to primary units, decimal, precision has to be 2 zeros. Let me go to fit, and the overall scale value, let me give a value of 10. And let us get back to text, and the text alignment has to be ISO standard, and the text placement, vertical text placement, has to be above. You click on OK, close it. Now we can see the dimension. Okay, now let us give the dimension for this length also. Dimension linear, give a click at this point, give another click here, drag it and just place it. Again take another linear dimension. Now from this point to this point, we are mentioning the height of the frustum, give a click here. Now in this problem we need two slant heights for our calculation purpose in the later part. So let me go to dimension aligned, click at this point and click at this particular intersection, drag it and just place it here. Now again go to align the dimension. Now click at this intersection and at this particular endpoint drag it and place it. Okay, now you can see the values are having decimal places. Now let us remove those values. These are only for our calculation purpose. So get back to dimension style manager, D enter, go to modify, go to primary units, change the precision back to 0. After noting those values, give a click on OK and close. Now you can see the actual values, they got rounded off. Now if you feel that these particular dimensions are making your diagram a bit clumsy, go to dimension style manager, D enter, go to modify, go to lines, and beneath the preview window you can see an option called a fixed length extension lines. Give a tick mark over there and this particular box gets highlighted and the default value in any system is going to be 1. Erase it and enter the value 0.25. Click on OK and close. Now you can see the dimensions are given there and they are not going to overlap with your diagram also. And now let us draw the development of this particular component, that is your cylinder. Now there is a particular formula for this one. Let me type that formula. Formula for development of lateral surface of cylinder. That is pi 3.14 into, that is 3.14, it represents the value of pi, into diameter, that is equals to 3.14 into the diameter of the cylinder is 20, and that is the value which we need. Okay, and in order to get this value, let me use a command CAL, which means calculator. Enter 3.14 into 20 and the value is 62.8. So now let us draw the development of this particular cylinder. As we all know in the basics, the development of a cylinder looks like a rectangle and the height of the rectangle is already known to us, that is 40, and the length of the rectangle is 62.8, which has been obtained by this particular formula. So let me take a line and let me give a click here. The length is 62.8, enter, and the height is 40, enter, and in this direction again 62.8, enter, and again in the downward direction, that is nothing but 40, enter, escape. So this particular thing represents the development of the cylinder. Okay, now let us give dimensioning for this one. Linear, give a click at this point, another click here in the downward direction. Now guys, look here, you got a value around 63. Actually 62.8 has been rounded off to 63. If you want to display the exact precision value, then go back to dimension style manager, D enter, modify, primary units. Now let us give a precision of 10. Give a click on OK, close it. Now you can see there. In the same way, again go to another linear dimension, give a click here, another click here, drag it and place it. Okay, this is the development of the rectangle, development of the cylinder, which has got into the shape of a rectangle of length 62.8 and 40 mm. The 62.8 has been obtained by this particular formula, that is pi into diameter, that is 3.14 into 20 mm. Now let us go for the development of the frustum. The frustum has been converted into cone in this particular modeling. So let us go with the formula for development of lateral surface of a cone. Okay, and before going that, this 66 represents the slant height. The 66 is going to represent the slant height, and this overall diameter is 70 mm, and the radius of this top funnel is 35 mm. Okay, now we are going to go take a note of the formula again. Again, I'm writing a text here, and now formula for development of lateral surface of a cone, and the formula is radius of the cone divided by slant height into 360 degrees. Okay, and the formula for development of lateral surface of a cone is radius of the top surface of the funnel, that is 35 mm from the given problem, and the slant height. The slant height is nothing but this particular value which we had obtained by drawing the front view of the funnel with the given dimensions. The slant height has not been given to us. By drawing on the front view of the funnel with the given dimensions, we have obtained this particular value 66. Now this is going to give us an angle here. Now let us do the calculation for that also. CAL calculator, enter, and the radius is 35 divided by slant height, that is 66, into 360 degrees, and the value which I got is 190.90. so I'm going to round it back to 190 degrees for our convenient purpose, or else you guys can also consider it as 191 degrees, but for our easy purpose I'm going to consider that value as 190 degrees. So now first what we have to do is, let us take a line. Now we have to draw two horizontal lines with the slant height, with this particular slant height, that is 66 mm. Now give a click here in this particular direction, 66, enter, escape. Now take another line. Now from this end point, give a click here again in this direction, 66, enter, escape. Now guys, let me change the color of this particular line for our understanding purpose. Now I have drawn two lines, each line having a length of 66 mm, that is which is equivalent to the length, this particular slant height. Okay, now the angle between this line and this line is 180 degrees. But from the given formula, that is radius by slant height into 360 degrees, I got a value of 190 degrees. So now I will rotate this particular red colored line at an angle of 10 degrees in the anti-clockwise direction, so such that the angle between this line and this line is going to be 190 degrees. So now let me take rotate command, ROTAT, rotate, enter. I'll select this line. After selection, I'll hit enter. Now I'll select this intersection or end point of these two things as my base point, give a click, and now when it asks for rotation angle, I'll give 10 degrees, 10, enter. Now the angle between this line and this line is going to be 190 degrees. Good. Now this particular length is 66 mm. So now let me take a circle, center radius circle, give a click here, and the radius of the circle is going to be 66, enter. Okay, after getting this one, trim the portion which is crossing both these lines. The command for trim is TRIM, trim. Hit enter twice, give a click here. Sorry, I had forgot about this particular text. Okay, just trim the portion of the circle which is going beyond both these lines. Now let me get back here. Now this particular portion, this particular slant height is 18.9 mm, which is equivalent to 19 mm. Now let me take another circle, center radius circle. Again give a click at this particular point, and the radius of that one is going to be 19 mm. Hit enter, and in the same way trim the portion of the circle which is going beyond both these lines. Trim, TRIM, trim. Hit enter twice, give a click here, and also trim this particular line and this particular line. Hit escape. So this is the development of the frustum of a cone from the given dimensions. Now let us give dimensions for this also. Take linear, give a click here, another click here, drag it and just place it. This particular length is 47, and now let us give radius dimensions. Go to dimensions, dimension radius. Now just select this particular circle, move your cursor up to your desired location, 66 mm radius. Again go for radius, select this particular circle, give a click. That's it. So this is how we have to generate the solution for the development of surface of a funnel. Thank you.